Today I'll be giving you a presentation titled Next Generation Aerospace Manufacturing Solutions for a Demanding Future. I believe a copy of these slides will be shared with everyone after this event, so please don't worry about frantically taking down notes or photos as we'll give you the entire deck. So my background then is, as Bernard kindly introduced me, so originally mechanical engineering. I then went on to Cranfield University to undertake a doctorate in friction welding, working with the Boeing Company and the Welding Institute. After that, I stayed on at Cranfield as a research fellow specialising in direct energy deposition additive manufacturing processes, before finally taking the jump over and joining the Welding Institute directly to work on a lot of their friction-based processes, primarily around aerospace and defence accounts. Now, at some point in my career, I was advised to join the business development team. Now, I like to think that was because I'm quite confident in talking. I like meeting people. And I hope it's not that everyone thought I was a rubbish engineer and was kicked into a BD function. But I guess that's for you to decide at the end of today's presentation. Next slide, please. Okay, so for today's agenda, first I'll give you an overview of the Manufacturing Technology Centre, why we exist, what our aims are, and some of the core capabilities around technology we have, and how these can be applied to all UK manufacturing, but with a focus on aerospace this evening. Following on from that, I'll give you a talk about some of the aerospace manufacturing areas we're involved in at the MTC and why it's important for us to be involved in manufacturing and changing the mindsets people have around this subject. Now, we do a lot of work at the MTC, and there's many wonderful projects I'd love to talk to you about today, but owing to confidentiality, I'm limited. So I put together 3 case studies where we have the opportunity to talk about some of the project work we've taken to support the aerospace industry. And then sort of towards the end of the presentation, I'll wrap up with quick conclusions, and I believe we open the floor for some questions and answers. So next slide, please. Okay, so the Manufacturing Technology Centre was founded not too long ago in 2010, starting operations in 2011. Now, we're an independent research technology organisation, and we're not for distributing profit. So our founding members were the University of Loughborough, Nottingham and Birmingham, along with the Welding Institute, and we had strong backing from the UK government by the Innovate UK scheme, who put the funds in to allow us to be impartial to support UK manufacturing for the greater good, as opposed to turning a profit. Now, on this slide, you'll see another couple of organisations listed along with the MTC. These are our sister centres. So some of you may have heard of the High Value Manufacturing Catapult Network. So this is the umbrella term for representing these 7 organisations that you see on the slide here. So the Advanced Forming Research Centre in Scotland, Glasgow, CPI Centre for Process Innovation in Newcastle, the Nuclear AMRC in Sheffield, which is associated with the University of Sheffield and is very focused on nuclear industry within the UK. The Advanced Manufacturing Research Centre at Sheffield, which again has a broad spectrum of capabilities. The Manufacturing Technology Centre at Coventry, just up the road from here, about an hour away. Warwick Manufacturing Group nearby as well, who are fairly heavily focused on the automotive industry, the electrification agenda around the automotive industry as well. And finally, the NCC, the National Composites Centre in Bristol. As you can imagine by the name, focused very much on composites. So although these 7 centres are independently set up and answerable to themselves, to get value for money for the taxpayer, we work with HBMC to sort of segregate the different areas that we support, so we don't overlap too much on capability and sort of waste taxpayers' money, as it were. Now, so why am I saying this? So from the Manufacturing Technology Centre, our core offering then is to support the defence and aerospace industry in the UK. Now, we have the capabilities to work with defence organisations across a range of classification levels. And from the aerospace side of things, we work in collaboration with our sister centre, the AMRC, where the AMRC are very heavily focused on the main structure of the plane, where the NTC support is primarily around the ancillary part, so the landing gear, the engines and cells and things like that. Now, even though after 12 years of operations, we're now at 800 staff, with over 400 of these having strong technical focus, and from an operations perspective, we turn over around about £100 million per year. Now, the £100 million breakdown, about £30 million of that is direct funded work from a client. They need something to support. We need support. We do the work for them. Now, a key item associated with this is any individual work we do for a client, they own all the IP. We're not interested in the intellectual property. Otherwise, if we're keeping a hold of this, it slows down the advancement of UK manufacturing. About another 35 million is associated with public funding calls, Innovate UK, European Union type things. 25 million is directly gifted to us from the government to maintain operations, and the remaining sort of 10 or so million is associated with apprenticeships and training from the work. Next slide, please. Okay, so the core areas then, what do we do? So this image shows us a picture of the headquarters based in Coventry. The building you see on the far left there, we do a lot of our training and apprenticeship scheme supports. I believe we're now the 6th largest provider of apprenticeships in the UK, which is quite impressive. The building you see in the foreground on the right, this is where our main laboratory facilities, where we do a lot of our technology development and research projects. In the back, in the far left, you'll see the High Temperature Research Centre. Now, this isn't technically a part of the MTC. This is set up by the University of Birmingham and Rolls-Royce to look at next generation materials for aero engines. But the MTC have a lot of staff seconded there to support them on these research endeavours. And the buildings hidden behind the tree at the back, this is our Aerospace Research Centre, where we do a lot more sort of some secretive types of work that gives us the ability to make sure nobody sees things that they shouldn't. And again, I won't systematically read through everything here, but we're very heavily focused on supporting factory optimization, production line efficiency improvements, research and development from the three things we discussed earlier, from public funding and direct funded work. And then we do a lot of technology implementation. Sometimes you don't need research, you need the existing product to be efficiently implemented into your production line to make things work. Next slide, please. Now, technology readiness levels, I'm sure many of you are familiar with this. So what's our niche? What do we support? Now, we know universities do the lower level technology work. Industry is very focused on the latter stages of the TRL level. And sometimes we see a lot of great technologies developed at universities that don't get much investment and support in the middle stage, that die in the valley of death, as it's called. Now, the MTC, along with the wider HBMC network, our focus is to hold hands with universities, take the great ideas they develop, really try that out and prove it, and progress the technology through the levels until we get to the latter stages with industry, where we can hand the technology over for implementation to support UK manufacturing. Now, once we've done our job properly and technologies are being developed and supply chains are being developed, we would then look to divest from those technologies, go back to the university, see what else is new, and carry the process on again. Next slide, please. Okay, just another sort of quick overview, then we'll get to the exciting stuff with the technologies momentarily. So really, top level, what's our strategy? Why do we exist? And the government have tasked us with these key things here. Improving productivity in the UK, helping justify people invest more into R&D to create high-skilled jobs. Not only from a technology perspective, but addressing the skills gap. It's all well and good developing these new capabilities, but if nobody's been trained to use them, it's a wasted opportunity. So we do a lot with colleges and upskilling training of staff, developing apprenticeship schemes for next generation technology capabilities. And really combining these things, the idea is that we can allow British companies to be much more efficient, allowing them to produce more and give them the opportunity to grow their export market. Next slide, please. So typically, why would an organisation approach the MTC? And it's based along these three things here. They want to make a product at lower cost or better quality. They want to assemble something with minimized reject rates, improved efficiency, or in this day and age of data where we have data being generated in almost everything we do, taking that data, harnessing it, and using it to help us make informed decisions from optimizing processes and the like. So based on these three core areas, products, assembly, and data, we go to the next slide. We've built our technology themes around these areas. So the row across the top is focused on component manufacturing. The row in the middle then is focused around advanced production and assembly, and the technology themes along the bottom row are around data acquisition and making use of that. Now, from a component perspective, we're heavily involved in additive manufacturing. We have the National Centre based at the MTC, and we work with a range of processes, which we'll discuss in some of the case studies later, from powder bed fusion processes to cold spray processes to the larger direct energy deposition-based processes. Non-conventional machining, this is effectively based around laser processing, using lasers to cut difficult to machine materials, adding functional surface textures to products, and also some laser-based welding. And then finally, high integrity fabrication, which is based around the hot isostatic pressing process. Effectively having a canister, putting powdered material in, heating it under pressure, and getting it to join to make a part. The advantage of the HIP process is that you can reduce buy-to-fly ratios from 40 to 1 down to sort of 1.5 to 1 for large, expensive materials as replacements for castings and forgings. Now, I haven't brought a large casting or forging with me today, but a few things just to pass around to those in attendance at the room. Here's one of the HIP components. So produced as is with a little tied up job. And this is a really nice part with some of the laser surface texturing.
So is this that when you produce this, why is it being machined out?
It depends on the requirements. So sometimes you might have a little bit of undulation on the outside and you just lick it up to tidy it to the desired part. Now the laser surface textured part there, that's just a nice show piece with some parts written on it, but we're investigating it for a range of capabilities. So if you think, for example, reducing drag on boats potentially, surface texture, the texture of a shark skin in a boat help reduce drag, things like this. It's quite an exciting new development that's getting a lot of interest. One other part I'll pass around is some of the additive manufacturing parts. This is a ceramic printed part, so although this part has no real function like ceramic adjustable wrench, but it shows you that you can print and assemble in one go out of ceramics. That's in alumina, that one, and this sort of technology is getting a lot of interest for potentially making ceramic blades for hot sections of engines, for example. Maybe you can run at higher temperatures and get
Sorry?
Yes.
Is it all made on?
So printed as an assembly, yes. Yeah.
Does one actually have the, you can say, tensile strength to be on a blade like that?
So onto the middle row, based around assemblies. So a lot of work around advanced tooling and fixturing, reconfigurable production lines. So we don't tend to produce a lot of things in absolute mass in real terms. So you don't necessarily want to build big production lines for different products you're doing. So if you can say you're turning over 100 parts a month, say, land-based vehicles, for example, you have one production line with your robots and automation that's set up to produce and assemble your first part. You put your quota, you're ready for the next part now. Update the systems model of robots reposition into the new part of your next part, minimising the footprint of production, for example. We do a lot of work with automating electronics manufacturing. Many of us are familiar with seeing images and videos from the other side of the world, big warehouses of people assembling PCBs and the like. So looking at ways to use automation to these back that manufacturing to ensure. And intelligent automation, this is a really exciting area, and we apply this in many different cases. Now, one example, so welding. In the next 10 years, it's estimated that about 70% of the welders in the UK will retire. But there's still a huge demand for welding to be done. Now, many children in the Western world in particular don't grow up of dreaming of being a welder, joining big lumps of steel with fumes these days. So we're going to lose those capabilities. So an idea to counteract that, where a lot of organisations are getting really interested about, is, well, if you have a robot, you have your pre-programmed welding setup, you have your weld on the end of the robot, you're encouraging the children, the next generation, to come in. You're not training them to be a welder, you're training them to use robotics and automation. And they're adaptable with that. You can remove the welding torch and put on drilling, something for prepping the edges of composites. So you're inspiring them to learn new skills that are transferable across industry, but you're still getting the fundamental technical requirement you need, welding or whatever it may be. And a specific welding engineer can program hundreds of thousands of jobs, and they're already on the system ready for somebody to use the robot. So we're getting a lot of interest from industry for this type of thing. Another example would be intelligent automation, similar to welding. Many children over here don't grow up and dream of picking apples off trees in the field or picking strawberries for supermarkets. So combining automation with machine vision processes and haptic feedback sensors, we've completed a few projects recently where you have a robot on track going down a farm, machine vision scanning to look, there's a strawberry. Is it coloured? Is it ripe enough? Is it the right size? Yes or no? If yes, haptic feedback. Take it softly, take it without turning it immediately into jam, and placing it ready for subsequent processing and dispatch. Finally, so the digital engineering theme. So we have a very capable team focused around design and simulation. About 50% of the team are focused on business factory optimization, designing factories to be lean, minimize downtime and the like. And the other half are very focused on physics modeling. So if we weld something at this temperature, what distortion do we get? If we design a part of an aerofoil, what improvements do we get in fluid flow and the like? Manufacturing informatics is saying this is taking data from all the machines that we're doing, that are running, understanding where we can make it performance improvements, understand maybe when things may need maintenance ahead of schedule. If the machine's running perfectly fine, why does it need to go through a maintenance cycle now? Let's keep the machine running. So having a much more organic, interactive factory that works with its workers to optimize production and output. And the final technology theme is based around metrology and non-destructive testing. Again, a very large, capable team we have at the MTC. Most of the projects that this team are involved in isn't directly something for metrology and NDT, but it's sort of a combined effort with maybe additive manufacturing, or printing a ceramic adjustable wrench. We need to know that it's good quality inside and it's dimensionally accurate. And they'll work with our other teams to make sure we're producing what we say we can do. Next slide, please. I won't go on this slide too much, but we work across a range of sectors. But the big ones primarily aerospace and defence, construction and infrastructure. We do a lot with transport, and I shouldn't really say oil and gas industry now because that seems to be a dirty word, but we are a power and energy sector where we're supporting a lot of companies with the electrification agenda, mass producing hydrogen and things like this. Now, for the rest of the presentation, I'll focus now more on the aerospace side of things and why we do what we do and some of the benefits we've given to industry. Next slide, please. Okay, so this is something we say frequently to people we work with. It's not just all about the product design. Let's think about manufacturing too. Now, there are some fantastic engineers across the UK and product designers, and they can design and come up with some phenomenal products. But by maybe backing off the complete optimal design of a product, 5% or 2%, we can allow much more appropriate manufacturing methods to be used to make that part, saving us lots of schedule costs, rework, and things like this. So our big mission at the moment in the aerospace industry is don't just think about the next generation product, think about the technologies that will be making that product and how we optimize the implementation of those technologies to make that product to allow you to hit your targets and grow UK manufacturing. Now, he seems to be the man of the moment in the news at the moment, so it'd be rude of me not to mention Elon Musk. But as Elon Musk said several years ago, and he repeated it again recently, manufacturing is building the machine that makes the machine. If you think the machine is important, well, the machine that makes the machine is also extremely important. More often than not, what I've found is that manufacturing is harder than the original product. We can make one prototype Tesla easily, but making thousands of them affordably with consistent reliability and performance and quality, that's the real challenge. And then he goes on to say possibly 10 times harder than actually making a prototype, making things consistently and affordably. And tagging on another aspect of that, making it in a way that reduces our CO2 emissions to help us meet our net zero targets. So this is where we really come in now, hoping we can see with the aerospace industry. Let's think about how we're going to make these products, not just the optimized design. Next slide, please. Okay, so why are the UK government keen for the MTC to support the aerospace industry with its manufacturing journey? As we know, there are many requirements for the UK over the coming years. I'll only touch on some of this meeting, we won't go into some of the politics that are going on, but achieving net zero targets, improving the output per capita for productivity in the UK, where we're far behind many other countries and their organisations without output. And again, reducing raw material usage. So this is where the government wants us to help. Next slide, please. So why aerospace? So I'm probably telling some of you guys facts that you're already aware of here, but commercial aerospace in the UK has sort of a £30 billion turnover. We've seen an almost 40% growth in the output over the last 10 years. And there's a back order of 13,000 aircraft that have requirements for UK manufacturing worth tune of almost 200 billion to the economy. So it's a big area for us to get involved in. Next slide, please. Okay, furthermore, so by 2024, domestic passenger travels expected to get back to pre-pandemic levels and continue to grow. I won't go through all the points, but due to all this increased air traffic, CO2 emissions are going to increase accordingly, and it's estimated that 21.2 gigatons of carbon will need to be abated between now and 2050. Hence, there is a massive preference in the aerospace industry for newer and cleaner technologies to build the aircraft. Next slide, please. And again, just a couple of facts. So Airbus intends to produce 75 A320s a month by 2025. Currently, their production processes are unable to keep up with this rate. So they're on the journey of improving their manufacturing processes. Boeing, again, huge demands of sort of over 30 a month for 737, and they're having similar issues with their production capabilities to meet this demand. And again, they're seeing an interest to increase the production of the 777. And again, there's serious concerns about how they're going to keep up with this rate of production. Moreover, a lot of the core materials that are required for Boeing and Airbus in particular, you think about some of your titanium alloys, there's concern that there's not enough titanium in the world at the moment with the current output that we're taking mining to keep up with the rate just with the aerospace alone, let alone everything else that uses titanium. From a geopolitical perspective, many of the large titanium billets come from Russia and China. So for an American and a European-based commercial aviation company, that's a concern. There's demand to reduce this material usage and find alternate materials and technologies to make these planes. Now, what we're seeing, as I'll go into in the next few slides, is this isn't a journey the big organisations can undertake themselves. They can find these new technologies, identify these new things, but if they don't involve their supply chain and keep up with them, the supply chain are not going to be able to fulfil the demand still, even with all these great new ideas. So next slide, please. Okay, and in addition to existing products, there are a range of new technologies that have been explored. So we see sort of electric, hybrid electric, hydrogen-based, multi-copters, hybrid lift, and artillery craft, and certain smaller size parts that can operate intercity, for example. Move to the next slide. Just to show, this is the increase in the number of alternate fueled aircraft over the last sort of couple of years. So we're seeing it really is growing rapidly in interest to move away from fossil fuels. So again, I won't go through everything, but the all-electric propulsion systems, hybrid electric and hydrogen-based alternatives, and you can see as of 2021, there are about 300 different concepts being developed at the moment. So we need to support production of existing aircraft and get aboard to develop ways to manufacture next generation alternate fuel vehicles. Next slide, please. I think this is the last slide from me before we go on to some case studies. And there's a lot of information here, and I don't expect you to read through it all in the next few moments. And as I said, the slides will be shared with you. So if you recall earlier, I spoke about technology readiness levels, and I believe many people in the engineering field are quite familiar with those. And you see the same technology readiness levels listed across the top here. What we're doing at the MTC now is focusing on something called manufacturing readiness levels. Now, historically, a technology would be developed through the chain we see from customers we work with, and once everything's idealized and optimized, we better think about how we're going to use this technology en masse now. So we go back to the beginning of the manufacturing readiness level chain to start developing manufacturing concepts, identifying a supply chain and progressing that. So to help improve production, what we're doing at the MTC is trying to overlap a lot of this where possible. So if you identify a technology you're developing, once we start getting to TRL 3 and 4, if this is something serious we're going to take on that we want to see in UK manufacturing organisations, let's start now thinking about how we're going to rapidly make this happen. So start doing supply chain readiness assessment development, and then developing the supply chain to be integrated with OEMs so that when we're ready to start a new product, the supply chain is already available to get going much earlier than historically there would have been. Next slide, please. Okay, so I've got 3 case studies for you now that I can talk about. There are a lot more details on our website if you want to read on these in more detail. So if we go to the first one, please. Okay, so an example of developing manufacturing technologies, we have a very good relationship with Rolls-Royce at the MTC. Now, several years ago, Rolls set us a challenge, and it was to develop the electron beam additive manufacturing process to produce parts for Rolls-Royce's UltraFan testbed engine to deliver further fuel efficiency, reduce engine noise, and CO2 emissions. Now, from an UltraFan perspective, I believe the ambitions are to reduce fuel usage by about 25% compared to the existing Trent engines. Moreover, the UltraFan has sort of about 70,000 horsepower, which I believe will make it the most powerful engine should it go into production. So from the MTC perspective, we worked with Rolls to look at about 240 different parts for this engine that we could start looking at ways to manufacture. Let's next slide, please. So a rather large project. So we built a 4,500 square foot laboratory. We filled it with 6 Arcan electron beam melting machines focused on titanium alloys. Powder handling processes, post-processing processes, a bit of machining, heat treatment, surface treatments and the like, and developed a range of NDN metrology processes to make sure that what we're making is actually what we believe it is. Again, so worked very closely with Rolls-Royce, the engineers from Arcan, the electron beam organisation as well, an integrated team to look at these parts. So if you go to the next slide, please. This is just a panoramic view of some of the machines in the facility. You can see all the different Arcan electron beam machines that were working flat out for a couple of years making these parts. Next slide, please. Okay, so the benefits. What do we do with Rolls-Royce then? So we successfully delivered 240 different aerospace components. These were primarily around parts associated with the engine for generating the electricity for the plane afterwards. All parts have full traceability from where was the powder source to make for the printing process. Has it been certified properly? Has it been stored properly in the appropriate gases before printing? All the data associated with the printing, the inspection, etc., etc. Fully traceable parts. Yeah, very successful project. And then on the back of this, Rolls have taken a lot of this development work to their own facilities, and we have some subsequent projects going on, and one I'll talk about in a moment. So again, going back to the thing, got a wonderful designed ultrafan engine, cutting edge. How can we manufacture that to help them achieve their goals, help reduce CO2 emissions, and additive manufacturing is an excellent technology to help organisations on that journey. Next slide, please. Okay, so case study 2, laser cleaning of battery cells to improve efficiency, reliability, and productivity. So the challenge to us from an organisation was to identify cleaning methods and technologies to improve the cleaning process and subsequently enhance the bond strength between the various different cells. Now, traditionally, these parts were cleaned mechanically or chemically. So if we go on to the next slide. So working at the MTC, looking at new novel laser technologies, can we use lasers as a mechanism for cleaning these parts to add value? So again, we investigated a series of trials to look at removing oxidation and contaminants from existing batteries that need maintenance and cells that have already been manufactured that are new but maybe been kept in storage waiting to go into the production line. So just cleaning off the cells using lasers ready before joining. So if we go on to the next slide, please. So benefits, using these novel new technologies, introducing the organisation into the supply chain that can support them with these new technologies to implement in their production lines. We're pleased to say we've got some significant improvement on the strength of the bonds between the cells. Moreover, the variability of the performance of the cells was drastically reduced to get a much more consistent performance, which we can plan maintenance schedules around. Moreover, the process using laser cleaners as opposed to mechanical or chemical, we improved the schedule by about 30% compared to traditional methods. And again, we're carrying on a follow-on project to start implementing these actual systems into production lines for certain organisations now. So the final case study slide from here, I know it's late on a Thursday, and I'm sure many of you are busy days at work tomorrow and don't want to hear me talk too long. So final case study, again working with Rolls-Royce, using additive manufacturing for making the front bearing houses for aerofoils on the engines. Similar to before, using the electron beam additive manufacturing process to see how we can produce these parts. So next slide. Okay, yeah, so a lot of similar work to what I discussed before about the processes that were taken in. As I say, you can do the final details when the slides are sent to yourself. The idea was for these big parts, we printed a series of the arcs. They were then TIG welded together at the end to get automated TIG welded together to get the final product. Next slide, please. Okay, and similar to the other projects, so using this approach, we reduced the time to manufacture the parts on traditional methods, 30% improvement. I don't have the numbers with me at hand. There's also improvements on manufacturing costs to produce the parts by using less material on the work. And again, another wonderful example of working with industry, so transferring knowledge to the manufacturing industry. These are the new processes you can do. But not only that, by the way, here's the supply chain that have been on the journey with us that are now ready to understand your needs and they can support you with your next generation manufacturing. So connecting the dots between the supply chain and the OEMs to support UK manufacturing. Next slide, please. Okay, so, yeah, so almost wrapped up now, but another 3 or so minutes. So conclusions from today's presentation, and then I think there's some questions and answers session, so do throw it. Like I say, in conclusion, the aerospace industry is recovering after the COVID pandemic. New designs and concepts are beginning to appear in conjunction with traditional products. Aerospace manufacturing is set to rapidly increase, but there are serious concerns about obtaining the materials to produce these parts and achieving production rates that are envisioned. The OEMs need to start preparing now to work with the supply chain if they're going to hit these production rates. And supply chains need to be brought on the journey. And at the MTC, this is sort of our modus operandi, connecting the big boys and girls with the small SMEs across the UK to allow these challenges to be met and to allow the UK to continue to be successful as a manufacturing country. Next slide, please. Okay, so in conclusion, a bit of shameless self-promotion of the MTC. So we're certainly set up to support aerospace organisations on their manufacturing journey. And from my perspective, I hope that was enjoyable for you today. And any of you who would like to pop a few miles up the road to come and see the MTC and our facilities and see some of the technologies and meet some of the engineers in person, we're happy to host you anytime you want. One more slide, please. Fundamental thing, so manufacturing is an integral part of product development and should not be considered as an afterthought. And if we combine product design with manufacturing thinking processes, it's going to be a promising future for aerospace in the UK. Final slide. Got my sorry about the image. I was happier, younger, and thinner there, but there's my details. So as I said, the slides will be sent out to you. So if anyone would like to organise a visit for yourselves individually or with your organisations, we'd be more than happy to host you. So thank you very much for that.
Excellent, thank you very much. We'll do Q&A, a little bit of time. Thank you again for everyone for your patience to be in the technical issues, but we got there in the end. Okay, so we'll check the chat and see what we've got. Okay, so we've got a question statement from Teresa S. So there you go. The comment about backing off design to improve manufacturing, improve schedules, cost, etc. reminded me of the message of the book Quality is Free by Crosby I read over 40 years ago, and the message is still valid. And got a question from if you want to.
So cost engineering is one of the most fascinating areas of engineering, especially because it's almost not considered in engineering education, because the accountants or the business and the MBA guys are doing that, which perhaps is discussion. But it's really difficult to estimate. So you've got your aircraft, you've got a design, concept design, time from the hardware, detailed design, how much will it cost? This is how we designed aircraft in the past and how much they cost, and now how much this one will cost. And then with the new processes, how much will it cost? Does that make the aircraft cheaper, more expensive? Is the entity engaging with that? And also, you mentioned carbon dioxide. How are you thinking carbon dioxide process change costs? Is the case that we think that new processes are always better, or maybe the world's put better in other ways. It's such a fascinating area, and you get to what I think is the most important sector. You get SMEs. How the SMEs for do the estimation. Do that. Is that something you're able to engage?
Absolutely. So working with a lot of engineers, we have a range of cost models for a lot of the new technologies. And as we've seen on some of the slides today, a lot of case studies, in general, a lot of these new technologies do add benefits. As with everything, it's horses for courses, and you see a wonderful part. You think we could use this manufacturing process to do that, and you put your data through the system and think, keep sticking at what you're doing. So it's very dependent. Now, from the cost thing for SMEs, a lot of the work we do with SMEs is people come up to us and say, what's the Internet of Things? What's Industry 4.0? What is digital engineering? What is additive manufacturing? My company for years has just worked on forming and pressing processes. We have legacy equipment we're thinking of replacing, but we don't know where to begin. So we do a lot of work with the SMEs to understand, not just continue to grow in their existing markets, identify new markets, work with them with their ambitions to do some of the cost modeling to help them fine tune, actually, we're going to replace that and we're going to get this new machine. Or actually, the machine itself is probably good for another couple of decades, but what we need to do is integrate metrology measurement systems onto our legacy equipment so that we're getting the digital twins for the parts we're producing. So It is very dependent, but the cost modelling of processes is a huge area that we're involved in for all the technology themes I showed on some of the earlier slides.
Brilliant. I'm going to jump in with a question. Anyone in the audience, does anyone have any questions? So, in terms of engaging with companies, what's the most difficult part? Is it familiarity with new technologies? Is it like the institutional inertia regarding we've always done it this way? Is it just like regulatory processes, or is it just like the availability of necessary technical skills? Like what makes it most difficult in terms of trying to introduce the human processes into industry?
Yes, I mean, as you all know, you work in engineering, it's you get very busy with the day job, and I did when I was doing the research, and sometimes you just don't have the time and the luxury to try and explore new things, not in significant detail to make an impact on what you're doing. So we try our best to do a lot of outreach work. Social media is a big thing these days with LinkedIn and the like. We host a lot of events, and we invite targeted people to come to these events to see what we're doing. I'd say out of the 3 technology themes I showed you, component manufacturing is really exciting. People like seeing the HIP processes, the ceramic adjustables, wrench and additive manufacturing. The biggest challenges I've seen since working at the MTC is along the automation side of things. Now, many people who work on the shop floor have this fear that by implementing robots, they're losing their jobs. This is not why the government backs the MTC to exist and make people lose jobs. It's to grow UK manufacturing, upskill and create new jobs. So some of the challenges I find around the automation side of things is that we're not implementing robots to replace you. We're implementing robots to upskill you. And with these upskilled, you can, instead of making a plane over however many years, you can make it in several months. You can make it in 7 months, you can produce more each year. If you can produce more each year than you require, you can start exporting them. You grow your profitability. So it's changing the traditional mindset that many people have, particularly around automation, I find. But we're slowly making progress in that area. Not that I can go into too many of the confidential projects, but working with some very large organisations and implementing automation to address these needs. And what's the most rewarding part is when you actually go to see the guys and girls on the shop floor that were originally so against it, and then you see them happily programming a robot going, it's making my job 10 times easier. They're being upskilled, more efficient, and you're enjoying your job more. So it's that's a nice success when you see that and change those mindsets.
So, okay, I think we've got 2 seconds. If anyone's got any more questions, put in the chat. If not, I think one last question. Yeah.
So, do you want to comment about the environmental map between small batch production to large industrial full rate production, and where it falls for things like automation and experienced machinists? Because there's obviously going to be some breakdowns on trade where it's not cost effective to automate it, but is part of the hospital looking for where that boundary is?
Absolutely. And on some of the technologies you just mentioned as well, one of the big areas that we look at, as I said, we have the National Centre for Additive Manufacturing. Many people, I was an additive manufacturing research engineer for many years. Many people think it's golden, but it's phenomenal. It's going to solve all the world's problems. But again, it's horses for courses. Depending on the product you're making, the volumes you wish to make, the process you wish to use, there's always that crossover in lines to see if it's justified or not. But what is exciting that we're seeing is the more we develop these new technologies, those boundaries are changing and becoming more affordable and justifiable for people to implement on these. And as you've seen with some of the big work we've done with Rolls-Royce, for example. Yes, so apprenticeships are definitely back on the agenda, a big support from the government on that. As I said, at the MTC, we're the 6th largest provider of apprenticeships now, and it's certainly been painted as this is a good career to go down, where, for many years it was sort of left by the wayside. But we have some fantastic apprentices going through our school at the moment from a range of companies. I'm pleased to say many of them go off and have successful careers in the companies that sponsored them. And on an even better note, sometimes quite a few of them actually come and join the MTC. They've been trained up for years, they've seen the technology, seen the companies we work with and the work we're doing, and put in the CV. So it's going well.
So yeah, I'll just get in one thank you again to the audience for our patience with technical difficulties, and if everyone can just say sort of give your thanks in the normal way.
Thank you for having me.
Thank you.